Welcome to the Explainer. We have absolutely all been there, right? Someone from another department drops by your desk or shoots you a message asking for just a quick spreadsheet of some database records. It sounds so incredibly simple, but as data professionals, we know that the bridge between a relational database like MySQL and a pristine, ready-to-use spreadsheet is just rigged with invisible traps. So today, we're going to navigate those traps together and execute a flawless, secure data export.
Look, we've all fallen into the trap of the manual copy-paste. You run a query, the grid populates with 10,000 rows, you hit Control-A, Control-C, and boom, your app instantly freezes into that dreaded spinning wheel of doom. And honestly, when it finally does paste, half the formatting is completely destroyed anyway. We really need to move away from this chaotic method and aim for our true goal, a clean, automated CSV delivered directly to your stakeholder. Manual copying isn't just painfully slow, it's practically begging for memory crashes and data corruption. We need a reliable, repeatable workflow here.
So let's ground this in a real-world scenario. Imagine a customer success manager needs a list of high-value transactions, specifically everything over $1,000 from last month. For this exercise, we're hooked up to a local MySQL sandbox using the sample Sequila database. Now, what's our absolute top priority here? It's pulling this data safely without leaking any credit card numbers or other personally identifiable information. The question is, how do we extract exactly what they need securely and efficiently?
Well, as a best practice, we always start by writing a highly targeted select query. Please resist the urge to take the lazy route and just dump an entire table with a generic select star. Instead, use a precise statement to pull only the necessary columns. You want to use strict where clauses to filter the rows down to that specific time frame, in our case, last month, and that specific dollar amount of over $1,000. If you just dump massive amounts of unneeded data into the Workbench results grid, you risk totally exhausting the application's memory buffer, which, by the way, usually caps out at 1,000 rows by default anyway. Targeted queries are quite literally the foundation of a clean export.
Okay, before your mouse gets anywhere near that export button, we have to talk about security. Protecting PII happens inside the query itself. First off, just drop any sensitive columns entirely if they aren't strictly needed. But if the stakeholder does need partial visibility, say just to verify a customer, you can use SQL functions to mask it dynamically. Think about using concat and substring functions to hide everything except the last 4 digits of a credit card number. You basically never want to let non-compliant data leave your secure database environment.
Once that targeted, secure query actually executes, it's time to review our realistic anonymized data right inside the Workbench result grid. You'll notice how the card numbers are properly masked down to just those last 4 digits. Taking just a brief, deliberate moment here to visually confirm the result set is safe, man, that will save you from the absolute nightmare of having to recall a compromised spreadsheet later.
All right, data is verified and we are finally ready to extract. We click Export Record Set to an external file. Now, I know the temptation to just immediately smash that save button is incredibly strong right now, but stop. Take a breath. We need to calmly walk through the dialog box options. We absolutely must explicitly verify our format, our field delimiter, and our encoding. Because blindly relying on the default settings here, that's exactly what triggers massive headaches for whoever is trying to open this file on the other end.
First up in the export dialog is the format. You want to deliberately choose comma-separated values, or CSV. CSV is the undisputed industry standard for spreadsheet compatibility. Relying on defaults in some environments might suddenly yield tab-separated values, or TSV, or sometimes even semicolon-separated values, depending entirely on your system's regional settings. And while those alternative delimiters definitely have their place in data engineering, sending a TSV or semicolon file to a non-technical stakeholder almost always creates immediate friction the second they try to open it in their standard spreadsheet app.
And now, we face the primary antagonist of data exports, the UTF-8 byte order mark, or BOM. This is a tiny hidden 3-byte signature tacked onto the very start of a file. In the wider world of encoding, UTF-8 is the absolute gold standard for representing international characters safely. However, Microsoft Excel is a bit quirky. It often requires this specific invisible BOM signature just to realize a CSV file is actually UTF-8 encoded in the first place.
Here's the funny thing. According to the standard RFC 4180, a BOM isn't even recommended for UTF-8.
It's technically totally unnecessary. But without it, when a user double-clicks the CSV, Excel panics and tries to guess your system's ANSI locale. Suddenly, all your special characters turn into garbled mojubake. You know what I mean, right? A word like école becomes a chaotic mess of strange, unreadable symbols. To make sure your French accents, currency symbols, and emojis actually survive the journey, we have to outsmart this encoding clash.
So, to bypass this encoding crisis completely, the absolute best practice is actually training your stakeholders on what we call the Excel import workaround. Tell them straight up, do not double-click the CSV file. Instead, have them open a blank Excel workbook, use Excel's native data from text CSV import tool, and manually specify the file origin as UTF-8. This entirely sidesteps the whole BOMEM issue, guarantees the formatting is preserved exactly as you exported it, and even gives them a preview window to adjust column formats before the data officially loads.
Beyond encoding, let's quickly run through a few other invisible traps on our checklist. We already mentioned the result grid's default 1,000 row limit, so definitely make sure your data isn't being silently truncated. Also, watch out for Excel's, let's say, helpful data type assumptions. It absolutely loves to drop leading zeros from zip codes, turning 01234 into just 1234. It will also routinely mangle long numeric IDs into scientific notation, so they end up looking like 1.23e plus 15. You can actually fix that by using the same Excel import tool we just talked about to strictly define those specific columns as text. Finally, just keep in mind that the Workbench UI is single-threaded, meaning it can easily freeze up on massive exports.
And speaking of massive exports, this brings us to a really important architectural distinction. If your query results exceed Excel's hard limit of 1 million rows, or if the dataset is just physically huge, the Workbench result grid is simply the wrong tool for the job. Workbench is memory buffered and optimized for ad hoc datasets under 1 million rows. For datasets over 50 gigabytes or anything approaching terabytes, you really must graduate to MySQL Shell's multi-threaded utilities, like the parallel table export. Otherwise, you're going to lock up your system for hours on end just trying to move data around. Assuming our dataset is reasonably sized today, we arrive at the final delivery phase. Now, before you send that file off, always perform a final dual check. First, open the exported CSV in a simple text editor like Notepad or VS Code, just to verify the raw delimiters and encoding. Then, open it via that Excel import method we just discussed to double-check the visual formatting. Only when it passes both of those checks do you hand off that pristine, Excel-ready file to your very happy customer success manager.
So, this methodical workflow saves the day, and it guarantees flawless data portability for those ad hoc requests. But it leaves us with an important final question to ponder. You've successfully managed a manual, secure export today, but how will you architect an automated pipeline when they come back and ask for this exact same spreadsheet every single morning? Think about how you can eventually transition from these manual GUI tools to scheduled programmatic exports in the future. Thanks so much for joining me for this explainer, and I genuinely hope you never have to deal with garbled spreadsheet characters ever again. Keep learning, and I'll see you in the next one.